project in early.
Bring everything over to here. Okay, we're good to go. So let's see. We got the speedruns group. And how's everyone doing? Everyone's saying in the chat that they're doing well. Just getting things reorganized. We got a lot of new fun things going on right here. If you have questions, feel free to ask. You're welcome, Rachel, of course. Sorry I was a tiny bit late there today. There we go. I think we got everything organized here. So feel free to ask your questions. Who has questions with the project, with anything else right now? I feel like putting the speedrun timer on here. I was been reorganized. How do you interpret the confidence interval in question 2? Great question right there. Let's look at that. So when we interpret an interval, so we have how do we interpret an interval, and then we've got the Excel graphic here. Let's do that. Let's look at this Excel. Some people have been reporting an error, so hopefully we're not going to see that error. But there's a speedrun timer, so it's now on the screen. I just want to go to the speedrun screen. The beard is probably just for quarantine. So I don't know. Someone's like, I don't know, like I don't know. I'm not used to it yet. Let's see here. We'll do we've got Excel, we've got 4C, and we've got, so let's do the how to interpret a confidence interval first. I am blank % confident that the true blank. Now this is the long one right here. Good, perfect. Look at that. That's awesome. Is contained in the interval blank to blank. So this is the biggest thing right here. This is where people make mistakes, is on the third one right here. So we'll do all these in order right here. Thank you for all the amazing questions. But if you look at how this is interpreted right here, I am blank % confident that the true blank is contained in the interval blank to blank. So what are we talking about? Well, it depends on if we're doing 90% confident or 95% confident. A lot of great questions in the chat. We will do all of them. But that's where we do our confidence. But here's where people make the mistake, is right here in this part right here. This is where the mistake is made. And I see a lot of question 4. We'll do some question 4 here in a moment. A lot of bandwagon question 4. I like it. So when we do this part number 2 that I've highlighted right here, this is so bright today and I don't have my full movement area. But when we do that part right there, the issue is people say the wrong thing. I want to point something out, and there's a huge hint for the project right here. But when you're doing, if something passes or fails or breaks, what is it? We have here fails and is safe. This is categorical. And so you would talk about the true proportion. So this here is proportions because it's categorical. But when you talk about days on the project is quantitative. So this would be the mean. So days on the project is quantitative. Does that make sense to everybody? That this one right here is categorical, and this one right here is quantitative. So when you talk about, and I see a lot of 3A, we'll do question 4, I think, next, then we'll go over to 3. But does this make sense to everybody here? Can we get some yeses in the chat that this makes sense, that when you're talking about days, it's a quantitative variable, like how many days does the engine last is quantitative. Nice, Joel, awesome. And so good to see everybody. Days is quantitative, so it has to be the mean. Or if something fails or is safe, is categorical, so it's proportions. I've got so little room here. I'm like reaching off the screen immediately. I need to reorient my camera again. But so all this right here, this is a huge hint for the project right here. You'll know what to put in this part here. This part here, part number 2, deals with the type of variable. If you're going to say the true mean or the true proportion, but just be careful. A lot of times people by default say the true proportion because they're just used to saying, I am 95% confident that the true proportion. But then we have to say the proportion of what? I put this so long right here because you don't just say the true proportion. You say the true proportion of machines that are safe is contained in the interval. I'm basically giving it away right there. I saw a lot of question 4s. Let's hop back over to the main screen right here. I've got all my buttons here to press. I don't think we should. Oh no, it's not going to happen. But we've got all the buttons today. This is our last little bit of fun right here before we get really super serious and do question number 4. Well, we've got our randomness button ready to go. So we got the randomness button. And then we got a new button, which I don't think Abby's here right now. But let's see if it works. Okay, you ready? We're just going to use our imagination today. So we're just going to try. We'll see where it appears. Probably can appear over me. Just doing it. Oh my gosh. What? Imagination just right there. And then it goes black because I couldn't make it dim out because I'm still learning how to use After Effects. Okay. So we've got a lot of, I saw question 4 next. Let's hop over to question 4. So I'm going to have to pull open the data right here. So that's our little bit of fun right there. So what did you do over the weekend? I learned Adobe After Effects. So I did. Well, I didn't learn all of it, of course. Let me bring up the data right here. So 2 seconds, I'm grabbing the data. And we're going to do question 4, which I think requires the data. So let's see. We are getting the data. And a lot of great questions I see going on in the chat right now. And here's the data in Excel. Let me pull open the project. Okay, then we go right here. Okay, we got the project. What were the question 4s people wanted? Question number 4. Okay, here we are, question number 4. Here we are. Okay. Hey, what's up, Sydney? Made in time for question number 4. Awesome. 95% confident. Yes, that is how we would say it right there. I am. But unless it's 90% confident. So unless it's God, that was amazing. 4C and 4E. Awesome. Okay. So in the Excel version of the data, we have to do the summary statistics. Now, once again, I'm going to hop over to jump real quick because I don't want to do the actual data right here. So I did different data last time. We'll hop over here to the haircut data real quick, and I'm just going to paste this all into Excel. So I'm going to copy with column names. I'm going to go into Excel. I'm going to paste it into Excel. Okay. So now we have the data in Excel that is basically like our data. I just don't want to do our project data, if that makes sense to everybody. I want to do a 95% confidence roll for the tips right here. So there are videos on this. Let's see here. We're doing 4C and 4E. That was the questions people want right now. Oh, it's about after you make it. Cool. A confidence roll can be used to perform a two-tailed test. Any value outside the interval can be rejected at a certain alpha level. And then are you able to reject your value of this value right here? Now, let's point to some really important things about this. So we need to be able to identify what's going on here. Now, this value right here is mu naught. And when you write your null hypothesis, this is a hint for other stuff. But when you write your null hypothesis, you do want to put that this value is the hypothesized value. Good morning, Tracy. Good to see you here. So you do want to put that this is the hypothesized value, and that kind of gives away the null alternative for earlier on. Now, this is not this question. It's in question 3, but it relates to it because this is the value we're going to look at in our interval. So let's go ahead and make an interval right here. I'm doing it on a PC. It's basically the same as doing it on a Mac. You just need to have the data analysis tool pack right here. There are some videos I have posted on how to get this. If you're having problems with it, please contact me. I hope that people aren't, but I've seen weird issues as of late. We're going to Descriptive Statistics. We're clicking OK. We're going to click the top column right here. We're going to click Summary Statistics, and we're going to click Confidence Roll, and then we're going to go to New Worksheet. Contains numerical. I didn't put there. Where's the button? Label in first row. Missed one button, and it said nope, because there's categorical data right here. I didn't click that. The label. The sound is low. Let me see right here. Let me bring the sound up a little bit more. Now the sound is higher. So how are we doing now, Tracy? I brought the sound up now. I changed the studio. So sorry about that. The sound should be higher now, and I should be much louder. Did that work? You're welcome, and thank you for asking. I looked, and you were right. The sound levels were a little bit low. I'm going to go a tiny bit down on that. Okay, good. So I've got a new thing. I've got a new way of muting myself, a whole new board and everything. So it's pretty cool. You had your computer 100%. Well, now we should be good right here. We should be back to normal. Now, if you notice in my previous video, I made this look all nice. We're going to do the real quick way here, making it look nice. You don't have to do these things. I do suggest clicking that. Frankly, the minimum amount of work that I would suggest to do to make this look nice is just to put a nice border on it. That's probably good enough right here. Like this right here in a report looks good enough. Now, it's not too hard to merge these two things right here to color it in. So that should be merged and centered, and then you can do fun things with these if you want with the borders here. I go to a regular border, then I go to the outside border. You have to do it in that order, and then you can delete this column right here because that's not needed. I just really believe in making your data look as nice as possible because we will be presenting this to people, so there's any which way you want to do it. And then usually I like to highlight the ones we're highlighting. So if you wonder why do I do all this, It's just because I want this to look really nice and presentable to whoever I'm trying to present this to. So I'm going to do this right here. I'm going to decide against that blue, and I'm going to go here, and then these are the values. Now, why do I do this? So we might, let's go to that. That's good. It's kind of like I want any colors work on these. I mean, you think, why are you using certain colors? What two values really are is your attention drawn to here? I'm kind of being more, we're going towards, like less time on the project, so I'm being more direct. Yep, and Rachel, you're doing the right thing right there, because do you see, I'm going to draw the formula on here, and I want to see if you see the parts of the formula in the equation. Y bar plus or minus T star times S over square root of N. Now, everything you need is on here to make a confidence interval for the mean. So this is a confidence interval for the mean tip that people give on haircuts. So if you notice, this value right here is Y bar. That is the sample mean. So the sample mean is right here, and this value right here, someone say in the chat for me, what is this value right here? I guess we did the arrow the other way. This value right here is the what? What is that value right there? Any ideas what that value is? Any ideas? What is that value right there? The margin of error, you're totally right. Nice job in the chat. You guys got it. So that's the margin of error right there. There are other things like this right here. This is the standard error. So that is the standard error right there. And then you have S, which is the standard deviation. So that one component is standard deviation. And then there's a count, which is this right here. So there's a lot of ways to solve this equation right here. You basically have all the key components, but it's much easier to just do the margin of error. It gives it to you. You don't need to solve for the t. You just literally have the plus or minus right here. So does that make sense? I drew it out differently last time. I'm always trying to do this different in case someone watches both videos. And you can see, okay, this is, it doesn't say margin of error, but it is the margin of error right here. So that's got this output right here. We know what's going on. Now, I want us to think about something. I want us to just look at this value right here and look at this. If I were to subtract, would 6 be contained in the interval, or would 6 be just barely outside of it? Like that's 0.67. So my interval right now is basically 6.70 plus or minus 0.67. So if I were to add and subtract from it, would 6 be just barely outside that interval? This is the key concept that people are asking about this question. So we're kind of learning it and making sure we know the concepts. Would 6 be in this interval or outside of it? It would be just barely what? It would be just barely outside of it. Nice job, Madeline. Just barely outside of it. You are right. It would just be just barely outside of it. And so what we're doing here is we're doing like an analogous problem. No worries right there. It's just be just barely outside of it. And you know what? I'm so interested to see if those points are working again today. Please be working points. I've redid everything. We'll see if it works. But it would be just barely outside of it. And since it's just, yes, I fixed it. And then it'll break again. So it'd be just barely outside of it. Now, this is the big concept people are asking about with 4C and how it works. With 4C right here, everyone's going to love their points now. With 4C, what do we have going on here? Nice job, Tracy. Here's what we have going on. The more you watch, the more you interact, the more points you get. Every 5 minutes you can talk and you get points again. So if you're like, why don't I have a lot of points? The more you talk, the more you interact, the more you get. And I was trying to fix everything up this weekend. Got new tech. So one of these days I'll stop remodeling my studio. I mean, that's when Chelsea and I have our place. So yes. So what do we have going on right here? This is basically the answers to the question. So people are all of a sudden like, hey, timestamp this. This is the answers to the question. So if we have a 95% confidence interval, if we make a 95% confidence interval, that's just like doing a what-tailed test. A 95% confidence interval is just like doing a what-tailed test. A 95% confidence interval is just like doing a what-tailed test. Two tails, you're right, Rachel, you got it. If you notice right here, I've got my two-tailed test. That's my does not equals test. And then the alpha level would be equal to what? The alpha level would be equal to what? The alpha level would be equal, hey, Julio, we got the points working again. So the alpha level would be equal to 0.05. So anything that is inside the interval, I kind of want you to see where this arrow is. Like if I put a line right here, if you notice that's inside the interval, and it's also not on the tails. So anything inside the interval you would reject or not reject. So take a look at the bottom graphic down here. I'll kind of put a line at it. Take a look at the bottom graphic. It's inside the interval. Would you reject or not reject on the top graphic? I didn't draw them perfectly analogous. So if it's inside the interval, think about this. You're saying, I think that's a possible value. So would you reject that or not reject it if you think it's a possible value? So if you reject it or not, what would you do? If it's inside the interval, we do not reject it. If it's inside the interval, we do not reject it. Imagine this. Your friend said to you, we're going to go get a steak dinner, and I think it'll cost between $20 to $30. And then you say, well, do you think it'll cost 23? Do you think it'll cost 23? Would 23 be a possibility? Your friend says, I think the steak dinner will be between $20 to $30. And then would you reject 23 or not reject 23? So they say $20 to $30. You would what $23? Because it's in the interval. So you said, your friend says, I think it'll cost $20 to $30. So 23 is a value you would what? Reject or not reject? Fail to reject. Lauren, you're right. And that's the wording we often use is fail to reject. So this is what I want you to think about is like these small examples like this, that if your friend says, I think the new car will cost between $10,000 to $15,000. What would you do to the value of $20,000 if your friend says, I think the new car you're looking for will be $10,000 to $15,000? You're looking for a very simple new car. I can't think of car types that are really cheap. You reject $20,000 because $20,000 is outside the interval. And that's when you'd have something over here. Can't draw on the screen today. You'd have something, there we go. You'd have something over here, which is outside your interval. And you notice that would land in the tail over here and you would reject. It's easier to understand like this, but the test would be a little bit different. So what's the proper way to word a response to 4C? I don't want to give it away exactly, but I'll try to make it more clear. So let's look at what we have right here for this example. With 4C, what we're looking at is any inside the value can be rejected. So what is the alpha level? Are you able to reject and what alpha level? So if we're able to reject the value, so we're mainly looking in on, let's make it very clear. Like I would probably give a good 2-3 sentences on this. Are you able to reject this value of this? And so how would we know to reject the value or not reject the value? Would you say, yes, that makes good sense right there, Rachel, what you're saying in the chat. I don't want to say too much out loud. What you're saying right there is what I'm talking about. You know to reject something because if it's inside or outside the interval you just created. And then what is the analogous alpha level? That goes back to our previous question right here where we have it all drawn out and we can see the analogous alpha level right there. Awesome. I like seeing that right there. I like seeing that when that makes sense. So good. Like you guys are doing excellently. That's what I want to see. I want to see people knowing what's going on because I like that right there. Let's see. Was it you guys wanted to talk about the other one right here? I think you guys wanted to talk about the other one right here. So let's go ahead and do this right here. Where is... I lost everything. That's what the chat's saying. That beard... You're awesome, Julio. It made it through the awkward stages. It grew up. So I think people were talking about D. So let's talk about question D right here. You're awesome, Julio. We'll have to see. I know you were saying you might grow a beard too. So I don't know. It's my first time with a beard. So Dr. Petrie, we just had a faculty meeting and he was like, you need to wait till fall. And I'm like, I don't think I can wait till fall. 4D and 4E, let's do 4D. In research, people hope to avoid a type 1 or type 2 error. Given the alpha level is fixed at 0.05, give one suggestion that the company could do to make a probability of type 2 error, lower the probability of making a type 2 error. Okay, so once you exactly, that's what I noticed. So the type 2 error right here, let's talk about how a type 1 and type 2 error kind of coincide. So it says that, let me just double check. I'm always afraid to put out wrong information. Give one suggestion. Okay. So it says that alpha is fixed. I wrote the project, but still I'm always like, oh no, I might say something incorrect. So here's the big lecture part of this. So listen in. This is stuff we need to know for the test. We have 3 things that impact beta. The 3 things that impact beta, so So there's beta right there. Beta is literally the probability of a type 2 error. So beta is literally your type 2 error. So you guys are cracking me up. We have alpha, we have sample size, and we have effect size. So if any of these go up, beta goes down. And if beta goes down, power goes up. Okay. So here is all the keynotes. You are right. Rachel is right. So this is all... Wait, I did it reverse there. Rachel, you are doing an excellent job. There we go. And so let me put a note right here on this. Does everyone understand that alpha is your type 1 error rate? It says that alpha is fixed, so we can't change alpha. So literally alpha is the percent of time that you are willing to make a false positive. Usually alpha is set to 0.05 by default, so it's the percent of time you would mistakenly reject the null, because we're saying 0.05% of the time, or 5% of the time, we will reject the null and say we have evidence, but that could just be due to random chance. So your alpha is your type 1 error rate. Now, as people say things like in my class, we always say A, B, 1, 2, plus, minus, because alpha is 1, which is type 1 error rate, beta is 2, which is type 2 error rate, A, B, 1, 2, and we often think of your alpha or your type 1 error as a false positive. In different contexts, it might be different. And I want to say one huge thing here, which I don't say enough. Type 1 and type 2 error, which one is worse, depends on the situation. So we can talk about what next problem here, what they might mean. But when you look at this right here, you might be able to think you could change effect size, but you really can't. Because Julio and I were talking about, who can hit a baseball further on average, and the effect size is what? Who here can tell me if we were to do a test between Julio and myself on who can hit a baseball further? So we go up to bat, we hit the ball 20 times. Can we video that? That'd be fun, but it'd be sad for me. Oh my gosh. Oh gosh, no way. I don't think I've ever hit it out of the outfield, ever. I mean, infield. Definitely not out of the outfield. But what would be the effect size here? What is the effect size that we're trying to measure when we compare Julio and myself? Think of what the effect size is. What do you think effect size is in this problem comparing Julio and Brian? What is the effect size? Rachel's going to jump in here and hit it further. What is the effect size that we're trying to measure right here? I think we've got Julio, we've got Brian, and how far they're hitting the ball. What is the effect that we're actually interested in analyzing? The difference right there, that's the effect size. And we don't control that. It's the true difference. Now, and to be more specific, the effect size is the difference from 0, because we're analyzing two means. So we're saying the difference between the two means. Exactly. And it's the true difference. It's the true difference. It won't be what we see. I know, right? Million points right there, Rachel and Tracy. It's not what we see in the sample. It's the true difference. Does that make sense? It's the true difference between the null and what we're analyzing. So that's what effect size is, which we don't control that. I don't control, you'd be like, well, you can hit the ball further, but it's like the truth. We don't control what the truth is. We can control kind of what we compare it to. So we don't really have control. Yes, points are working again. We don't really have control over effect size. So what do we have control over? Well, if we wanted to lower our chance of making and think about this. I like that makes sense. When would we be most likely to make an error in judgment with sample size? When would we be most likely to make an error and say there's no difference between Brian and Julio with sample size? When would we be most likely to make an error, which is a failure to reject the null? Let's say we make a type 2 error, which is when we fail to reject the null. When would we be most likely to make a type 2 error with sample size, which is when we don't have evidence? Think about this. When would we be most likely to say we can't reject the null because we don't have evidence with sample size? Like, what sample size might lead to that if Julio and I, and kind of how small of a sample size? Think of the smallest sample size possible and be like, well, that's not really enough evidence. You're right, because they're inversely related. If sample size is small, then beta goes up, which is type 2 error. One swing and I missed and you hit it. Yeah, exactly. Exactly, Julio and everyone, you're getting it. Less than 5, you're right. Very small sample sizes are likely to make type 2 errors, because type 2 error is when we fail to reject a false null. So there's your type 2 error is when you fail to reject a false null. And so we definitely would be more likely to make a type 2 error when we have a small sample size and we are more likely to fail to reject the false null. Because Julio is better than me, and so we should reject that Julio's better. We should have evidence that there's a difference or evidence that Julio's better. But due to the small sample size, we just didn't observe it. And that's when we didn't have enough power, because if you're likely to make a type 2 error. So I think I made it pretty much clear. If you look at what's on here right now, you can't just screenshot it and see the answer. But does everyone understand what you could manipulate? I can't hit it further than Julio. So there's no way. There's like, you could get one sample where I get lucky, and you'd be like, well, Brian's not horrible. But no, it's baseball. Sadly, Julio, I do like baseball. I was a huge fan of it growing up. Very quick story. My brother and I had a radio, and we would listen to the Braves at night. We would just turn on the Braves, and we'd listen to the Braves while going to sleep. We lived in North Carolina at the time, so Atlanta was, the closest place, and our neighbor, Mr. Baker, was a huge fan of the Braves. And I remember the Twins World Series with the Braves. I guess that was like 94, maybe 93, maybe the Twins World Series. So with Tommy Glavine, Steve Avery, Dave Justice, all those people right there back in the day. And so I was kind of into baseball, and then I kind of got into Boston because my roommate was into Boston. Go Cubs! Though we got some Cubs fans in the background right here. So but I don't know. I'm like the least sports person there is. I'm all video games. So that's got this question. We'll do the next one here. Is everyone pretty clear on this question about what we can probably, if you look at the screen, manipulate? Oh, you failed so. Oh, you did Julio. You're the best. You're my favorite baseball player. So 4E, let's do 4E right here. Let's hop over to 4E. 4E. In context of your research, what would a type 1 error mean? Provide information to the executives to help them understand what decision this would lead to and what this error would be. Okay. This question right here, I think people often don't take seriously enough. And what does making this decision mean? So when we look at this right here, let's go back and let's write out a null and alternative. Now, once again, we're going to write our null alternative, then we're going to talk about a type 1, type 2 error. And we're going to do a simplified version of this, and then we're going to talk about the version you're doing right now. So my favorite example we do in class, and I think I know how to spell scurvy. We're going to say no scurvy. Is that it? Does it have the E? I feel like it does or doesn't. Who can confirm for me the spelling of scurvy? Someone in the chat, help me out. You guys have the auto check. You guys have the is like survey, but is that? I'm gonna go with this since no one says no E. I knew it had no E. I knew that looked a little bit weird right there. Thank you right there. You guys are awesome in the chat. I'm just having you guys get those chat points because we got Streamlabs back, so I'm getting everyone talking in the chat. So it has no E. Okay. So we have a null hypothesis here, and we have an alternative hypothesis. So now we're in the medical industry, and we want to say, what are the consequences of a type 1 error? What are the consequences of a type 2 error? And so let's think about this right here. You guys are awesome in the chat. Thank you, Julio and Joelle and Isabella and Lauren. So I want us to think about this. Now, here's what you have to do. I think I can still reach up here. Good. I just disappear over here now. So look at this right here. Here is the null. Here is the alternative. When you go to the doctor and they have no idea what you have, they're not going to assume you have scurvy and test that you don't. They're going to look for evidence you have scurvy. So the alternative is the evidence-based claim. Now, when the doctor says you have scurvy, they're not going to say, we know you have scurvy. I mean, they might say that, but they might say, we believe you have scurvy, or there's good evidence you have scurvy. Does that make sense on kind of how we talk in statistics? I wouldn't say, I know this person has this. We'd say, the tests show evidence that you have scurvy. I mean, they might say you have scurvy, but in the real precise wording of it, we're saying we have good reason to believe you have this. And then when the test comes back negative and you don't reject the null, you would say, we do not conclude you have it, or there was no evidence you have it. Does that make sense? You don't say, I have concluded you don't have scurvy. You would just say, there wasn't evidence of scurvy. So we did not find evidence of scurvy, so we retain the null. Negative tests don't reject null, exactly. And that's what we think here of like false negatives. So when we do let's put our little notes right here to help us out. When we do 1, 2, A, B, plus, minus. Now let's pause here. Here's what we got to say. In a type 1, does everyone see the 1? In a type 1, the null is what? I want to see it in the chat. I want to see what this, Brian's making a certain letter here. Brian's making a letter with his fingers. In the type 1, the null is what? In a type 1, the null is true. You guys got it in the chat right there. Tracy, nice work. In a type 1, the null is true. So if the null is true, what would be the error with the null? If the null is true, what's a mistake to do with the null? If the null is true, it would be a mistake to do what with it? If the null is true, it would be a mistake to do what? Let's say the null is true. We're just going to say the null is true. So it'd be a mistake to do this to it. Reject it. Exactly. If the null is true, it'd be a mistake to reject it. So in a type 1, the null is true. It is true that Brian does not have scurvy. But we're going to reject it and say he has scurvy. Does that make sense? So if I'm going to interpret this to someone, I'm going to say, well, a type 1 error would mean that somebody does not have scurvy, because in a type 1 error, the null is true. They do not have scurvy. But I'm going to reject that, and I'm going to say there is evidence that they have scurvy. Does that make sense to everybody? So I'm once again, look at your null and alternative for the test you're doing, and talk about it in like a common way to say, well, in the type 1 error, this is a true thing right here. This is true. Brian does not have scurvy. But we are going to reject that. Good job, Sam. And we're going to say we have evidence he does have scurvy. So in the medical sense, a type 1 error would be putting someone on medication for scurvy or a treatment plan when in actuality they don't have it, because remember, the null is true. And then in a type 2 error, does everyone see the 2? The null is what? In a type 2, the null is this. It's not me blocking my face right here. The null is false. And we do what? The null is false, and we got to say the second F here. The null is false, and we do something with the null. The null is false, and we what? In a type 2, the null is false, and we what? The second F you have to say. In a type 2, the null is false, and we fail to reject it. You're right. There's the second F right there. And do not reject, fail to reject, same thing. Nice job, Cameron, and Tiffany, and Abigail, and Rachel. Great job. So let's look at it and say it in context. It is false. This is a type 2 error I'm talking about right now. It is false that Brian does not have scurvy. This is a false statement. So if it's false that Brian does not have scurvy, what is going on right here? So I think Julio got it. You're right. So it is false. You got it. Great comments in the chat. It is false that Brian does not have scurvy. So Brian actually has scurvy. Brian not having scurvy is a false statement. So Brian actually has scurvy. Like, it is false that Brian does not have scurvy. Does that make sense? It is false that Brian does not have scurvy. So Brian has scurvy, but we are going to fail to reject the null and continue to believe that Brian does not have scurvy. So in the medical example here, you would say, well, when you make a type 2 error, it's a false negative. And we would say that Brian, once again, I'll review that here in a second. In a type 2 error, we would say, it is false that Brian does not have scurvy, so he actually does have scurvy. So Brian does have scurvy in a type 2 error, but we failed to reject the null, and we would say he does not have scurvy. So to sum that up, Brian is told he does not have scurvy when he actually does. And then the type 1 error is the reverse. I think Rachel has it right. Yes. No, a type 1 error is a false positive. In a type 1, so we say, it's so easy to mix these things up. That's why I'm so careful with my wording. So let's look at it again. In a type 1, the null is true. So what is true about Brian in a type 1? Remember, in a type 1, the null is true. So I want you to look at this and say, so in a type 1 here, Rachel, you ready? In a type 1, it is true of this about Brian. What is true about Brian in a type 1? In a type 1, what is true about Brian? In a type 1, what is true about Brian? Julio is correct. You're all right. Julio is correct. In a type 1, and so I want to make it very, very clear because we have to be exact with our wording. I think that's where people get confused. So, and I'll do one more example here with this too. In a type 1, it is true that Brian does not have scurvy, but we reject that and tell him he does have scurvy. In a type 2, it is false that Brian does not have scurvy, so Brian actually has scurvy, but we tell him he does not have scurvy. Does that make sense? You always have to slow it down. You have to be like, in a type 1, the null is true. It is true that Brian does not have scurvy, but we reject that and tell him he does have scurvy. Let me review your type 1 again, Rachel. Sorry, it's so... In type 1, we say he doesn't have scurvy when he does. No. If we tell him he doesn't have scurvy, that would be a type 2. Because the only way to tell him he doesn't have scurvy is to do what? The only way to tell him he does not have scurvy is to do what to the null? The only way to tell Brian he does not have scurvy is to do what to the null? The only way to tell Brian he does not have scurvy is to do what to the null? Any ideas? The only way to tell Brian fail to reject. And so when you see that F right there, remember your F, it's a type 2 when you fail to reject the null. And we always talk in terms of the null, like I failed to reject the null. So if you tell Brian he does not have scurvy, you have failed to reject the null. But if you made an error, Brian actually does have scurvy because the null is false. Correct. And think about that. So Rachel, perfect job right there. That's a false positive right there, because think what a false positive is if Brian does not have scurvy and you tell him he does. I know, right? And so it's so easy to flip. But a false positive is when Brian does not have scurvy and you say he does. Does that make sense what a false positive is? Like, I'm totally fine, and you say to me, Brian, you have scurvy. And I'm like, oh no. It's a false positive, though. I don't actually have scurvy. So it's a false positive right there, because the null is true. In a type 1, the null is true, but we reject it and we say we have evidence Brian has scurvy. So it's a false positive on the test. That's why I do the false positive right here on the very bottom, the 1, 2, AB. I'll do one more example of this. I think we have time for a few more questions here. Sorry for being a tiny bit late there, and also everything else. Let's say, let's do, this is not your example, but let's say we were to test the true proportion of machines have less than 80% or have greater than 80% that are safe. So if you were to do this test, so always go back to your null and alternative in the project. I wanted to make sure I don't want to do everything, but this is super project related now. It's not your null and alternative. Your null and alternative is something like this right here, and then you'll have to figure out the alternative, but that's the null for your project. Does that make sense? Awesome, Tiffany. So good to have you here. So you're welcome, Rachel. So this right here, I'm going to say we did another test on the project to see if the proportion of machines that are safe are greater than 80%. So let's say we are doing a test to see if the proportion of machines that are safe are greater than 80%. And let's think about the implications right here. So the company is looking for evidence that their machines meet this threshold of safety. Like the proportion of machines they make are greater than 80%. Does that make sense what they're looking for evidence of? They want to see if there's evidence of this. And they'll probably go with the new machinery if they meet this threshold of safety for the new machinery. Does that make sense what I'm trying to test right here? I'm trying to say, do we have this good reasoning to think that our machines will meet this threshold of safety? Awesome. So now, what is a type 1 error? And this is really related to your project right now. Like, it's very similar to what you're doing. So, so they tested the machines to see if they're safe or if they catch on fire. And we want to know that over 80% of them are safe. We want to see if we have good evidence of that. So I want us to slow it down. I want us to write, I think Emma might have it right here. Let's read Emma's answer. A type 1 error would be that if Nissan said it's greater than 80%, we're safe. Basically, and so you pretty much have it, Emma. The last little bit I would just word differently. And that's amazing, Emma. Great job right there. So we would say, because once again, in a type 1 error, the null is true. And so it is true, and I guess, Emma, you did an amazing job right there. Emma, you could just, as long as you change your wording, you've basically got the answer to I'm going to just throw the pen down. You basically have the answer to the question. So this is true that the true proportion of machinery is equal to 80%, but we're going to reject the null, and we're going to say we have evidence that it's over 80%. So what would they do? This is huge hints for your project. What would the executives choose to do if they think that the machinery has a proportion of safe that is greater than 80%. In this type 1 error, what would they do? In the type 1 error, what would they decide about getting the new machinery if they think that the safety is above the threshold they're looking for? Would they choose to buy it or not buy it if they think they cleared the safety threshold they're looking for? And this is a type 1 error. Because in a type 1 error, the null is true that we are not above the safety threshold, and the alternative, they would buy it. You're right. So they're going to say, oh, we've got all this evidence that we meet the safety threshold in the type 1 error. They're like, okay, we meet the safety threshold. We're good. Remember, but the null is true, but they rejected it by accident. And now they're saying they have evidence when they actually don't. So they've made a type 1 error here, because in a type 1, the null is true, but you reject it and say you have evidence when you actually don't. Now the type 2 error, so in a type 1, they're going to buy the machinery when they shouldn't. Hint, hint, hints. And then in a type 2, they're going to fail to reject the null when the null is false. So if you fail to reject this null, what do you currently believe? What do you currently believe? Emma, amazing answer. Let's see. Anyone else know what we're going to do in a type 2 error? Remember, in a type 2 error, the null is false, but we fail to reject it. This is a 2, and these are 2Fs right here. The null is false, and we fail to reject it. So what would the company believe, and what would they decide based on that with all this right here? So what would the company believe, and what would they decide in a type 2 error? What would a company believe, and what would they decide in a type 2 error? Let's see some amazing answers in the chat. Who's got some great answers right here? We'll make Emma a mod. We have so many mods. Thank you to the mods, especially when we're doing these live streams that we have people come in. It's always good to have mods. So in a type 2, the null is false and we fail to reject it. So let's look at it. It is false that the machines have a proportion that are safe that is equal to 80%. So the machines are actually above the threshold. So they would believe, well, so wait, be careful. Here, I'll slow it down. I'm going to talk about the type 2 error again. Don't worry, it's so easy to make mistakes on these. Here's what I always suggest doing. Remember your statements. In a type 2, the null is false, and we fail to reject it. So look at the null and say the null is false. It is false that the proportion of machines is equal to 80%. And they're going to say that it's greater than. And so, oh wait, we fail to reject it. Sorry, my gosh. It is false. See, it's so easy to make a mistake. It is false that is equal to 80%. So they actually are greater than 80%. The truth is this one. Does that make sense in a type 2? The truth is this in a type 2. But I think that someone just said, they're saying, let me see. The type 2 error would be that you say the machines don't meet the threshold correct, but they actually do. Rachel, you got it. Rachel, you put it even better than I could have put it. See, great job right there. You're getting it. The type 2 error would be that you say the machines are not meeting the threshold because you're going to fail to reject this in the type 2, but they actually are meeting the threshold. Does that make sense what the type 2 error is? Is you're going to say, we're going to fail to reject this, but you've made an error because this is actually true down here. So you're failing to reject this, and you're saying, they don't meet the threshold, but they actually do because the null is false in the type 2. Always remember, the null is false, and you fail to reject it in a type 2. Does that make more sense, Rachel? Do you think you have the hang of this problem? And great job working out right here. That shows a, it's so easy to, you'll notice I'll even slow down because I've caught myself making mistakes talking about it. It's so many trues and false, and this is actually this. You have to slow it down. You have to do it once again. You have to say, we'll do the type 2 again. In a type 2, the null is false, and we fail to reject it. So I'm going to fail to reject this right here. I'm going to still believe it. So this is what I believe, but this is false. So I'm going to believe we're not meeting the threshold, but that's false. We actually are meeting the threshold. We are meeting the threshold, but I failed to find evidence for that. So that's what a type 2 is. And then a type 1 again is this is actually true, but I'm going to reject it. It's true that we are not meeting the threshold. Like in layman's terms, this is we're not meeting the threshold, but this is false. So in a type 1, the null is true. Oh my gosh, see, I just did it. In type 1, this is true, but we reject it, and we say we have evidence when we don't. So, sorry, even I'll make a mistake every once in a while. That's got it for that problem. I think we got time for just a few more right here. Which other ones were you guys thinking about? I saw some stuff earlier, like 2 and 3. Which question, if you're here right now, you get to pick the question we're going to do next, which might be one of our last 2 questions. Which one are people thinking about? 3A. Let's go to 3A. You're welcome, Isabel. We can see a lot of, we got 3A, 2B. Let's do 3A, and I think we got time for 2B. So let's take, or not 2B. That's the lamest joke I've made in a long while. I'm just going to hiccup away. So let's go here and go to 2B. So create a confidence interval for the true proportions. 3 conditions must be met. Okay, to make a confidence interval, we need to go in here to jump, and then we go here. And we go here to analyze. Let me make this full screen. Did I do 2B? I did 2B. Where is it? Sure, we're doing 2B right now, and then we'll do 3A. Go in order. Okay. So, some big things to mention. You have a question about 4? Awesome, Sydney. Ask it away. Put it in the chat, and I'll go back to it here. So, whenever you make confidence intervals, you can do it the following way. And I want to point something out. If you're doing something like, let's do payment method, you will get this right here. And these are box plots. Oh, that was made up, Sydney. That was made up as an example. Great question right there, Sydney. That was a made up fake example. No, don't worry. That was a made-up fake example. I appreciate the question. I just made that up for a fake alternative. And for yours, you will use your null and alternative from earlier on. You'll use the mu equals 3600. So you'll use that from earlier on. Does that make sense, Sydney? You'll use your mu equals 3600, mu greater than 3600. Just giving some answers right there. You're welcome, Sydney. Great questions. So here we are with some output that you made earlier for this. Yep, this video right here, and then there's the video last week. There's the video last week where I also worked through it too. So let's go through confidence interval. Let's go to 90%. So if you notice, we get some 90% confidence intervals right here. And the biggest thing right here is I think for this question, we're talking about the conditions. So let's make sure it says to create a confidence interval, what are the conditions that must be met? So this is the big thing. Condition 1. What's condition 1? I want to see it in the chat. We got enough time to do these last 2 questions right here. What is condition 1? I'm hopping over and I'm doing another video. Random. And how do we know it's randomly sampled? Well, we took a random sample. So it's randomly sampled because we took a random sample. So that's key right here. We took a random sample of 300. So we have a random sample. So random is condition 1. Condition 2. Does anyone know what condition 2 is? What is condition 2? Any ideas on what condition 2 is? What is condition number 2? 10% condition. You are right. Nice job, Rachel. So condition 2 is 10%. And then we get to condition number 3 right here. Condition number 3 is going to be based on the data. So we need to look at the data, and then we pause. But for this one, for question 2, so we always pause here. Does anyone want to pause yet? So in this one right here, we have to do either nearly normal, or I'm going to run over myself, aren't I? Or we need to do success failure. So right now we'll have a different one. Sorry, there's a few things to memorize in this class, but we always pause. And how do you know which one of these to use right here? Nearly normal is quantitative, success failure is categorical. So there we go right there. There it is. Nearly normal is quantitative, success failure is categorical. So what are we doing right here? Bingo, you guys got it. That's why we pause. And there is I'll mention it next class. We'll talk about the last condition. I don't want to add confusion today. But there is a new test we'll be doing, the chi-squared test of independence, coming up here. So when we take a look at this right here, our data in this question is going to be what type? So what would the third condition be right here, and do I meet it? We'll look at my data. My data is categorical. These are actually bar charts. They're not actually histograms because they're categorical data. So we have here bar charts, and I meet it because I have 126 here and 106 here. So this will be success failure for the third condition because it's categorical. Because we asked someone, what is your payment type? Kind of like asking if it's safe or fails or catches on fire. So this is categorical here. Bar charts said that they have spaces between them and categorical. Yeah, so you'll notice here that it's got the category down here, making it categorical. So you will get these bar charts online. So it said that online? Awesome. Does that make sense what the conditions are? And I think, does that answer the question for 2B? Is it okay to make them separate? Maybe. Send me it. I'll take a look. I'll see how it looks. What you really need for especially this question is you need these percentages right here. Yeah, I mean, I'll take a look. You just need these percentages. You need the conf rolls. 3A. Let's go ahead and take a look at 3A. So create a histogram right here. Include the graph and interpret. Okay, good. This is an awesome one. Then we'll do 3C. I tell you guys what, I'm gonna send one text. I can still like, wait, I can still vanish. Oh, look, I'm gone. You can still hear me though. Be right back. Okay. Oh, I hit the I hit the random button. I can disappear myself. I can mute myself instantaneously. I've got all the buttons now. And we've got our rainbow, so we can do our imagination now. Oh my gosh, there it is. Imagination. And then it goes black. So I'll figure out how to make it fade normally. So random. We love it. Okay. So we've got a few on 3. We'll go for another like 5-10 minutes. I was 10 minutes late on you guys, so sorry 474. They're probably in the video right now being like, "Where's Brian?" But we'll hop into their video next here. So let's go to 3, create a histogram, interpret it. Okay, let's do that. So when you create a histogram right here, because I'm using different data, the first thing we want to talk about is the shape, center, and spread. So how would I describe this? Well, interestingly enough, when we talk about shape, center, spread, usually we start by talking about the shape first. Can I get some stuff, so random, can I get some stuff in the chat right now about the shape of this? Can anyone tell me, like, what's going on here with the shape of this? Like, what is the shape of this? Any ideas about the shape of this right here? This one is not the shape yours is. And these are the big things. Skewed to the right. Yes, nice job, Rachel, right there. It is very skewed to the right. It is unimodal, skewed to the right with some extreme outliers. And I'd probably say there's an extreme outlier at 40. So I just talked about kind of an unusual feature also. So with this right here, we know that it's a right skew histogram that is unimodal and has at least one extreme outlier, someone who tipped $40. So because of that, we can now talk about the center and spread of it. Because this is skewed, the proper measure of center will be what? I like it. Like, I think people might have more points now by the end of it. Because this is skewed, the proper measure of center will be what? Since this is skewed, the proper measure of center will be what? So since this is skewed right here, the proper measure of center will be what? That's so cool. Streamlabs is awesome. What will be the proper measure of center because this is skewed? The median, you're right. And the median will be the proper measure of center, so the median tip was $5. And then the IQR is the proper measure of spread, which tells us the middle 50% had a spread of, and we have to compute it. You can add it to the output. But here's the thing. If it was not skewed, the proper measure would be the mean, the center would be the mean, and then also the spread would be the standard deviation. So the proper measure, and think about this also, that might help you out for later questions, because if you're saying it's kind of normal, that kind of like goes along with the nearly normal conditions. Because think about this, if you conclude that it's normal kind of to start, well then the nearly normal condition says that if it's normally distributed, we can do these proper measures. Does that all make sense? Yes, both Joels are here. I love it. And I'll be in your guys' ear here soon. So yeah, hang out here if you want. But you guys are so awesome. I love the positivity in the chat. I love it. So does that make sense on how to answer this question, what we have going on right here? We have also got our 95% confidence intervals up here. So we're good to go on this. Does that make sense what we're looking for? Don't just be descriptive with your answers. Like, here's how I would answer this. This distribution looks to be unimodal with a very strong right skew, and there's an extreme outlier at $40 where someone tipped this amount. Because of the extreme skew and outliers, the proper measure of center for this distribution would be the median tip of $5, which represents the 50th percentile. The proper measure of spread for this distribution would be the IQR, which is $3, which represents the span of the middle or the range of the middle 50% of tips. Does that make sense that that would be my answer for describing this right here? I wouldn't just say it's unimodal right skew, center is this, mean is center is this, spread is this. You want to kind of walk someone through and explain what each thing is in context. That's the key right here. Is you're writing a report. You're not just answering questions. You're being like, you know, because of this, we're doing this. This is the right measure of center because of this, the right skew and all this stuff. Does that? Can you say that again? Sure, I'll do it again. So here's my interpretation of this shape, center, and spread. The distribution of tip amounts is very right skew with an extreme outlier of somebody who tipped $40. It is also unimodal with the peak around the center, which is the median of $5. The median of $5 represents the 50th percentile that people were tipping, and we would expect 50% to tip above this and 50% to tip below this. The spread of the distribution is best measured by the IQR due to the skewness, and this represents the middle 50% or the range of the middle 50% of tips. Now be careful. My distribution right here is very skewed with outliers, so I'm using median and IQR. Yours might not be skewed in outliers, so you might want to talk about a mean representing the average amount. You might want to talk about a standard deviation representing the spread from the mean. The standard deviation is a measure of spread from the mean for normally distributed data. So does that make more sense right there, Rachel? I'm kind of dropping some hints. So we choose for 3, right? Well, you will choose if it's mean or median and standard deviation or IQR, but if it's normal, use mean and standard deviation. If it's skewed, use median and IQR. Does that make sense, everybody, on this one right here? I think hopefully that makes sense to everybody. I think we're good on that one. So I've kind of dropped some major answers in there on how to do that. And I think we had a few more, and we'll do, because I was 5 minutes late to them, Joel and everyone. I was 5 minutes late right there, so we'll do the last little things right here. It depends on student normal. You're right. Oh, the size of the confidence. For this one, oh, does it not say? Oh, I'll have to tell the graders that. No, this one is, we're doing 3 right now. In 2, you do a 90% confidence, and then I guess you're not interpreting a confidence roll for this one. You don't make a confidence roll right here, so we're good. And then for 3B, or I think people wanted like 3C. So now I'm going to do a test on it, and this is so big. Oh, good. This is the last good 5 minutes right here. So I'm going to do something crazy right here. Ready? So here's what I'm going to do. People are really, yes, let's do some 3D, because 3D and 3E are basically the same. So this is an email I've been getting a lot, and I'll have this in a video. So if you're watching this right now, hello, I probably sent you this video. But don't worry, please email me. It helps me see where people are getting stuck on the project. And then people are very confused on something, and let's talk about what they're confused on. Where people are confused right now is, let's do a comparison right here on payment type. Now I'm going to look at this data before I do it. So this is awesome here, Sydney. Yep, we did that earlier on. Check it out, Paxton. Rewind the video, and you'll see it in the video. You'll see it probably about 20, 30 minutes ago. Check it out. You can rewind a live video. So we're going to go here to tip amount, and then, oh wait, I want to go to analyze distribution. And we're going to go to tip amount. This is currently, we're doing 3. You're welcome, Paxton. We're doing 3 D and E. We're doing 3 C and D, 3 C and D. So we're going to go to tip amount here, and then we're going to go to payment method here, and let's put it in, and let's stack the distributions. Awesome. Now I need to look at this. Okay, good. I think, let me look at the standard errors. Okay, perfect. I'm going to test $7. Okay, so I don't want us to think about statistics for a moment. You're like, wait a minute, I'm in a stats class. Why are you telling me not to think about stats? I want you to just look at this mean right here and tell me about how much people usually pay for a tip on card. How much do people usually pay for a tip on card? How much do people usually pay for a tip on card? What was the average payment for a tip on card usually? It's usually around how many dollars? $4.97, you're right. Basically $5. Let's keep $5 in our head. And then I want you to look at the average tip, and I want you to just round it nice and neat. I want you to look at the average tip with cash is very close to what? Just round it up, make it nice and neat. And you'll see why I chose $7. So the average tip for cash is about how much right now? And cash is not going to be as crazy. Basically $9. So we have one that's $5 up here, and we have one that's $9 down here. Now, if I test to see, nice job, Joel. If I test to see, both Joels, if I test to see that the average tip is more than $7, which of these would I have evidence for probably? Card is more than $7 or cash is more than $7? Which of those would I probably have evidence for? I could probably have evidence for one of these. Or the only one I could have evidence for is what? That card is more than $7 or cash is more than $7? Which of those cash? Oh, and yes, you are correct. Oh, that's so awesome, Joel. And so we would probably have evidence for cash. So if we have evidence, what's the p-value going to be? If we have evidence, because remember, we're looking to see if we have evidence that this is more than 7, and this one is more than 7. I'm not saying we do have evidence yet, but this one's lower than 7, so how are we going to have evidence that it's more than 7? So, like, if I told people I could hit the ball into the outfield, then what would be evidence I could hit the ball into the outfield? If I kept hitting it into the infield, that wouldn't be evidence. But if I was hitting home runs, that would be evidence because I'm going above what you expected. So does that make sense right here? So this one is below where we think, we want to see if there's evidence of more than 7. So this is below that, and this one's above this. So do you expect the p-value for this test to be, let's go to the bottom one here. I know I keep switching it. This one is the one where we have evidence. So the p-value on this test to see the greater than should be small or what? We have evidence right here. We probably will have evidence. P-value will be low. Rachel, nice job. Let's mod the other Rachel right here. P-value will be low. You said it. So for this bottom one right here, we're going to test the mean of 7, and we get a low p-value. So if you notice right here, the p-value is low right here. Does everyone see that? There's the low p-value right here for the greater than test. This is the does not equals test. This is the greater than test. This is the less than test. And we do have evidence right here, the one I'm hovering over, that we have evidence that the true mean for the tip amount is greater than $7. Now, don't always go to low p-values because remember, we're testing greater than. But this one, we will not have evidence, so the p-value will be what? We will not have evidence, so the p-value will be very, very what? We're not going to have evidence that's greater than 7. we're going to have basically no evidence here that it's greater than 7. We're going to fail to reject the null. The p-value is going to be very, very what? High. You are right. The p-value is going to be very, very high. And if you look here, here's the same position. Do you see how it's position number 2? Big, you got it. Nice job, Abigail. So we have here, it's greater than t. High, just let the null fly. We do not have evidence that the tip amount is greater than 7. So if you notice right here, in this test, the p-value is very high, and we do not have evidence that the true mean is greater than $7. And if you're wondering why doesn't it look shaded, we can actually show this. I didn't show this last time, but let's go to p-value animation, and let's show the greater than test. If you notice, this is your p-value of basically 1. It's just not shading it because they don't think you would want to test that. You can see the test, the observed value right here. That's the sample mean. There's the mu naught, the hypothesized value, and it's the same graphic being made, but now we can see the 100% shading. Because a few people emailed me and they said, I don't see the 100% shading. It's just jump only shades the smaller p-values. It shades the smallest one-sided and shades the two-sided. But here is the shading of the 100% for the greater than test, because it's when it's greater than you shade to the right. Does that help this make a little bit more sense right here? We would only have evidence, and this is basically your problem. We only have evidence that the cash amount is greater than the hypothesized value. There is no evidence for the card amount that the card amount is greater than the hypothesized value. And I've basically, who sees how analogous this is to the project? If someone's like, hey, that is just like the project he just did, and that's the way a lot of statistics are. You might say, well, I don't want to talk about that. You might say, well, Brian, you can't do the test because it's not normal. And I'd say, well, large enough n condition. So what was your null hypothesis here? Great question. That's a good place for us to end on this. The null hypothesis for this test that I just did was, remember we have our 3 steps for writing the null. When we write our null hypothesis in statistical notation, we write out 3 blanks, and here's how we practice it. So we put our 3 blanks, so always try this out. Blank number 1 is going to be the population parameter we're testing. Blank number 2 is going to be a statistical sign, and blank number 3 is going to be the value. So what value did Brian hypothesize was true? What value did Brian hypothesize was true? Sorry, I'm hiccuping. What value did Brian hypothesize was true? Do you remember what value I hypothesized was true? What value did Brian just come up with to test? You're right, Rachel, it's 7. So 7 would go here and here. And then the null has the equal sign. Brian tested to see if it was greater than. Awesome. And then we were testing the mean because it was quantitative. I was testing how much people tip, which is a quantitative amount. So we were testing quantitative amounts. And sorry, my 7s look like the greater than sign. So Brian's bad handwriting is making this very hard to read. So this is very similar to your problem. Again, you'll have a different hypothesized value, kind of dropping some major hints. This is the only part of what you'll have that will change. I didn't put P over there on the side because this is not proportions, but then you have to look at the, yes, exactly. You have to look at the P value to see if you have evidence for the alternative. Does everyone see this sign right here? This will be, I think we'll be in the other one in 2 minutes. If you look at that sign right there, I can't find my output right here. That sign right here is the greater than sign, and you'll look at the greater than p-value. So don't always go to the small one. We're still doing a greater than test right here, and we don't have evidence. The p-value is very high. We don't have evidence for the alternative, so I would fail to reject the null. We don't have evidence that the true mean is greater than. And look at this. I found a mean of $5. I don't have evidence that it's greater than $7. Does that make more sense right there when I talk about, like, since I'm failing to reject the null, I don't have evidence that the mean for what people tip with card is greater than 7. I don't have evidence for that. I would fail to find evidence for that right there. That makes more sense? Awesome. So I'm really hoping a lot of this made a lot more sense. Do you guys feel a lot better about the project? How are people doing? It's my last question of the day. You guys can check your points too. I'm about to head out of this video, and we'll play our Rick and Morty outro to end. But do people feel better about the project? Is it making some more sense? We covered a lot of the project today again, but check those points. Keep remember, you chat, you get points. So hopefully people are feeling good. I've got to head over to the other video and help them out. So we're going to do their lab. Are we including the last screenshot into the graphic? You will include these screenshots right here. You will include these tests. You can include if you want. Wait, that's power. We're not doing power right now. You can include like this right here. You could include this. I'm probably going to fix it so the text is not on top of itself. But you could include this as your statistical test. That's a possibility. So that's got it. Let's say hey to Rick and Morty, and I'm going to head over to the other stream. So here's some Rick and Morty outro for you guys.